They're just going to wait till it fails. And in that case, since nothing's been done preventatively, it's going to fail prematurely. We've had engineers who have said, you know what, I'll do that and I'll handle it. And then after the first or second project, they come back, you know, I think we'll go ahead and have you package that on the next one. Because at the end of the day, phasing a project does legitimately cost more money long-term, but it's less money up front.
If you've got a shipping container and a piece of equipment that's bigger is in the middle, do I've got to take all the stuff out between that and the door potentially to like get that piece out and service it if it's a bad enough break?
Yeah, I mean, what we offer is one nectaring, if you will, so that you don't have the, you know, this going on when there's an issue. It's one phone call and that goes, you know, to all of the equipment on site. Every state's a little bit different in terms of how they categorize the reuse, but at the end of the day, there is no reason that you can't or shouldn't be implementing the reuse as a part of the project. So some of the beneficial reuse, some other kind of
critical failure points, like from an operations side that you see you guys have designed around. All right, everyone, thanks for coming on today's show. I've got Troy here again with Cloacina, and we're going to talk about wastewater plants. Thanks for coming on, Troy.
awesome favorite topic.
So, all right, so one of the things I see as a really good fit for Cloacina is with developers who are like trying to plan and get plants in. Can you kind of explain to me some of the high things that they should be considering when planning a wastewater plant, and maybe how you guys come in and can make a huge difference for them?
Yeah, so the way that we kind of approach things is we take a big step back. We try to understand what all of the needs of the developer are, both short term and long term, and try to match one of our products to their individual development needs. And you know, we have a pretty wide variety of products, everything from just a couple thousand gallons a day all the way up to the, you know, 500,000 to 1 million gallons per day range. And we have products that are phasable. So we look at it from the standpoint of, are they the type of developer who's trying to minimize the upfront capital because maybe they're going to flip the project later, or they're going to hand it over to something like a utility district, or are they going to go gangbusters and have an incredible absorption rate? So they want to bring in everything ready to go for that. Some of that also is in tandem with the actual permitting, because sometimes the permitting necessitates certain features of that. But so we really try to sit down, you know, meet with them and or their engineer, talk through some of those things, understand where they're coming from, and then put together a cohesive plan and match all of our products to that.
So an example of wanting to go all gangbusters, as you said, would be, you know, they've got 100 lots or a bigger player coming in, and they really want to attract it. So they're like, hey, we're going to put in that bigger set now, so that I'm blanking on the name of a larger like development group, but that they're going to come and buy the, you know, 500 acres next to our property, and they're going to want to connect in.
Yeah, so some of the times a developer is looking to attract bigger builders, right? Because they'll chop up or create sections of their development and then sell off bulk and wholesale sections of the development. Or sometimes they want to sell everything to one particular builder. And so oftentimes in those situations, they want to put all of the utility infrastructure in place at the very beginning, so that they don't have to screw around with the additional costs that are associated with a phased project. Because at the end of the day, phasing a project does legitimately cost more money long term, but it's less money up front. And so if it's a 10-year time horizon, it probably makes sense to spend more money over that 10 years, but less money up front, because they're looking to scrimp and save on every dollar up front. But if you're talking about a 2 or 3 year time horizon, it probably doesn't make sense. So you might as well just go all in at the front end.
Yeah, that makes complete sense. And then talking about kind of with your system specifically, that initial install, a lot of them work with just general GCs, right? They work with guys that do pipeline. Maybe pipeline's the most complicated thing they worked with your system. And explain to me why that's such a benefit, why that can be a benefit to them working with those kind of GCs.
Well, depending on the arrangement of the project, whether we're coming in and doing something turnkey or if we're just offering the products, it's a little bit different in terms of how we interact on the project. But at the end of the day, we have solutions that are essentially a la carte that can round out the entire project. So we can go all the way from the pump station through disinfection and everything in between. So the nice thing, whether we're doing it turnkey or we're coming to an engineer like yourself and essentially offering the suite of products, is it's one-stop shop. And I try to, we as Cloacina try to make it so that you don't have to go looking externally for any other, solutions within the fence lines of the wastewater treatment plant. So that's one of the benefits. And frankly, a lot of times when we're talking to people, what we offer is one nectaring, if you will, so that you don't have this going on when there's an issue. It's one phone call, and that goes, to all of the equipment on site. And I've had engineers who have bought just our MBR, and they said, I think I can do other things a little bit cheaper because the appearance is that on the surface, some of our externalities, so let's use the UV disinfection. If you look at our packaged UV disinfection and you just compared it to the UV reactors, well, of course it's more expensive. But by the time you factor in all of the other things that are associated with that, the engineering, the design, all of the additional equipment, the control panels, the integration, all of that, when you
wasted all that money just thinking.
That's right. And so we've had engineers who have said, what, I'll do that. And I'll handle it. And then after the first or second project, they come back, I think we'll go ahead and have you package that on the next one because they'll have headaches with one individual piece of equipment. They'll call us and it's like, well, look, you bought that elsewhere. Yeah. It's hard for me to support something you put in on the site.
That's outside of kind of your wheelhouse.
That's right.
You know what you're good at.
Yep.
I think you use the analogy of like how Fords are built, right? Like you control all those parts and you can guarantee a result.
That's right. And in that analogy, a lot of times we come into a project and it's sort of the person building a hot rod in their garage. They have the responsibility of making sure everything fits together. They've got to deal with the rolling chassis and the engine and the transmission. And frankly, if they have a problem with one individual component, they don't get to blame anyone but themselves and that individual component. They can't call the engine manufacturer about a problem they're having with the engine and the transmission interface. It's their problem.
Right. They're the one time
right.
All together.
Versus you park your Ford F-150 in the garage, and if you have an issue, you call Ford. It's a single point liability.
That's a great point. So you're talking about your UV disinfection. I'm seeing a lot of people asking me about reuse and applications. Is the water that comes out clean enough to get reused in other places?
Yeah, absolutely. I mean, that's one of the benefits of the MBRs is it's, as far as biological treatment, it's the upper echelon. It's the top shelf. We come from California. It's the land of reuse. Pretty much everything has to be reused now. And so really it's been a complete and total reuse centric focus for us. And so every state's a little bit different in terms of how they categorize the reuse. But at the end of the day, there is no reason that you can't or shouldn't be implementing reuse as a part of the project. So some of the beneficial reuses that we've seen implemented on projects are as simple as just offsetting groundwater pumping to go out to agricultural lands. Others are more creative where they might go in and offset, other water intensive uses, maybe that they're doing on an industrial portion of the project. And we've seen it all. I mean, all the way up to
potable. I'm not potable. Sorry. Like a toilets stuff, landscaping, just
Yep.
at an adjacent development too.
Yeah, exactly. So in a lot of our projects, we'll do the ornamental landscaping, and we'll sort of break the potable out from the landscaping, and we'll all of the sort of ornamental landscaping that you see running around the development. All of that is irrigated with our reuse.
Pretty neat. All right. So talking about the operators, I've seen some plants that are very tight and feel like it'd be hard to work in there, and maybe not even the space and everything. What should operator be considering or wanting out of their wastewater plant so it's really easy for them to come in, do their work, do their job, if they had a say?
Well, so I mean, all of us at Cloacina and the management and ownership team, we came from the operations and maintenance world. That's where we were forged. And so all of the approaches of everything that we've baked into Cloacina really have been with the operator and maintenance man in mind. I think I've told you before, it's sort of like the ultimate car is one that's built by a race car driver. Somebody that pushed it to the limits and knows how every single thing should interact in a perfected manner. And so some of those things are, concepts like access to equipment. Others of them are just simple things of how something is implemented or integrated onto a project so that you can actually work on it when there's a problem. A lot of the times we've seen issues in terms of somebody will actually implement a piece of equipment and make the gross assumption that you'll never have to work on it. You'll never have to isolate it to get to it.
It's nature; it wears out. They
have this idea that you'll never have to work on it, so we don't need to worry about valving it appropriately. And I think you said maybe it was a Freudian slip, but you said something that was interesting, which is working in something is difficult. And, that's where you'll see in the industry, a lot of people are shoving things into C trains and things like that. And that becomes a maintenance nightmare. Because now to get to something, it's behind things, it's on top of things.
Oh yeah,
it's difficult to get
quick
to.
Question about that, because I honestly don't know. So if you've got a shipping container and a piece of equipment that's bigger is in the middle, do I've got to take all the stuff out between that and the door potentially to get that piece out and service it if it's a bad enough break?
Yeah, I mean, in short, it's just much more difficult when you put things into a C train. And that's really why we've never designed anything to go into a C train. It's sort of from my perspective, it's more of a low buck entry level approach to things, and it's cheaper to build. It has certain benefits, climate being one of those, right? That's a legitimate benefit of a C train type approach. But the real problem,
climate meaning like what, like not climate change, meaning,
yeah, like if you had to go into a rural town and it was subject to freezing and things like that, that's probably a good application for that. However, the sacrifice is that if and when you have an issue, not if, but when you have an issue inside of there, and you have to take a pump out, it is legitimately much more difficult to do so. And some of those things, some of the pieces of equipment that are shoved into those C trains were really difficult for them to put in when there was nothing in there, and they're practically impossible to get out of there when there's a major issue. And that's just the nature of the beast. So that's why we've completely shied away from any of that style project, because I can't in good conscience hand over something like that to somebody where I have to look them in the eyes and say, yeah, this is easy to maintain, because it's not.
Right, because that's what you have in mind. What are some other kind of critical failure points, like from an operations side, that you see you guys have designed around?
At the end of the day, so we have owned an operations company since 1999. So going on almost 25 years now. And at the end of the day, what I realized is this: it's really simple. If it's not easy to do, they're not going to do it. So if you make someone's life hard, they're not going to do it. And so at the end of the day, what I have found is if you don't make access to equipment, and that's both maintenance access, but also visible access, then you're not going to get the appropriate operations and maintenance tasks done. period. They're just going to wait till it fails. And in that case, since nothing's been done preventatively, it's going to fail prematurely. And that's sort of the sort of undergirding principle that we operate on at Cloacina, which is make everything easy to see, everything easy to get to, everything easy to work on to the maximal extent that we can. Design with that in mind, and that's sort of our guiding principle.
Right, and then they'll love it.
That's right.
And it'll sit. I just think of so many times engineers are probably the worst at what you're saying is they'll over-engineer it and add too many layers, make it more complicated, think you need more, and it's too complicated. And then what happens is no one ever manages the thing.
Yeah, and I mean it's extremely. I'll admit it's extremely difficult to design things with that principle in mind, and here's why. One, it's really difficult to know how you have to operate and maintain individual pieces of equipment. That requires a ton of tribal knowledge. The other thing is that also requires years of experience doing said task. And that tends to be the disconnect with to generalize with most engineers is they didn't come from the operations world. They weren't in the field necessarily. And so the better engineers that we've worked with over the years tend to be the ones who either came from that world or are sympathetic to and pay attention to and ask questions of the people that are in that world and take that feedback and close that loop on their designs. But it's tough. It's really, really difficult.
You know, it really reminds me what you just said. So I listened to Elon Musk's biography, and they talk about the roofing company, and no one's allowed to design the solar panel roof designs unless they've actually spent, I don't remember, it was crazy. It was like 1 to 3 months in the field, like an inordinate amount for an engineer to do.
Yeah.
You guys have already been there. Everyone at your business who's got a hand in this. So it sounds like that's working well.
Yeah, there's a current analogy in the vehicle world that's pretty applicable here, which is if anyone's popped the hood of a vehicle nowadays and seen that you literally can't get to anything, and they've completely plastic shrouded over everything and made it so that you can get to it, you realize that is clearly not designed by a mechanic. Versus you go back in time, to the 50s, 60s, and you realize everything was designed, the vehicles were wider, the fenders were set up in a certain way, everything was set up for the mechanic. And then at some point, there was some regulations which required additional equipment to be put into the engine compartment. There's no doubt about that. But at some point, there became a significant disconnect in the feedback loop between people who were working on vehicles and people who were designing vehicles. And they stopped talking.
It's a really, really good analogy. I got to say, that makes so much sense. Just going back to Elon, that's how they design the rockets. For example, he went all the way back. If you can't explain to me why, or he went so far as if you can't tell me the name of the person that wrote the spec that we're following, then we're going to throw it out and find out if it works without it.
Well, and he has some really good guiding principles, which are essentially work to always simplify it back constantly. Simplify it, and then see if you can simplify it further. And we do the very same thing. So there's a lot of times that we have internal arguments about the best way to do it. And at the end of the day, if we can't decide on one because there isn't any overriding reason to go one way or the other, my filter is really easy. Which of those is the simplest and has the least amount of moving parts and requires the least amount of input from the operator? Do that. Because if everything else is equal, always go with that. So if you can return something via gravity, do that in every instance.
Yeah, less pumps to break.
That's right.
Wow. Cool. Well, thank you so much for taking this interview and the time.
Yeah, absolutely.
Knowledge.
Thank you.
Yeah.